Good morning, dear student. In today's lecture, we are very much interested in the reaction of glucose with a reducing agent. So, if you see the reaction, that is a glucose molecule react with S2 in presence of nickel or sodium in presence of ethyl alcohol. This S2 in presence of Ni and sodium in presence of ethanol, it is act as a reducing agent. Okay, it is act as a reducing agent, and this aldehyde group it get reduced to alcoholic group. So in this case, whatever the aldehyde group of this glucose, it is converted into the primary alcoholic group, that is CS2OH. Okay, and if you see the same reaction with fructose, so if you see here, this is your fructose molecule. This fructose again react with reducing agent in presence of S2 in presence of nickel and sodium in presence of ethanol. Okay, it will gives, yes, it will gives sorbitol. Okay, this is your sorbitol. Okay, so in this case, the ketonic group of this fructose is converted into the secondary alcoholic group. It is converted into secondary alcoholic group. So we know that this reducing agent, when it react with aldehyde, so it will convert the aldehyde into primary alcohol, and when it react with ketone, then it convert the ketone into secondary alcohol. So this is fructose, it is your ketonic compound, so it will convert into secondary alcohol. Okay, the second carbon, that is C double bond O, get reduced and it is converted into CHOH, and in this case this aldehyde group is converted into this CH2OH group. So aldehyde is converted into primary alcohol and ketone is converted into secondary alcohol in presence of reducing agent. So you should keep in mind the reducing agent is there. So sometimes sodium borohydride is also used in this reaction. So glucose in presence of sodium borohydride, sodium borohydride, it also gives the sorbite. Okay, so this is the reaction of this glucose molecule with reducing agent and the fructose with reducing agent. Okay, it is as simple as it. In presence of oxidizing agent, we already discussed, that is the aldehyde group is converted into acid, while in case of reducing agent, the aldehyde group is converted into primary alcohol and the ketonic group is converted into secondary alcohol. So both glucose and fructose on reaction with reducing agent gives sorbitol, gives sorbitol. So let's discuss the second reaction of this glucose molecule, that is reaction with phenylhydrazine. Reaction with phenylhydrazine. Reaction with phenylhydrazine. So what is this phenylhydrazine? This is your NH2 NHC6H5. So this is your phenylhydrazine. When this glucose molecule, so we know that this is your glucose. Okay, HOH, then here OH, H, then HOH, HOH, and finally the CS2OH is there. So this is your glucose molecule on reaction with this phenylhydrazine, that is NH2 NHC6H5. So C6H5 is nothing but your phenyl group is there. So we know that hydrazine is your NH2 group. When one of the hydrogen of this NH2 group, it is replaced by the phenyl group, then it is converted into phenylhydrazine. Then it is converted into phenylhydrazine, and this is your glucose molecule. This is the glucose molecules, and we know that after reaction with three molecules, okay, so you have to take excess phenylhydrazine. So one molecule of glucose react with three molecules of this phenylhydrazine. Okay, and it will forms the derivative of this glucose molecule, and it is known as ozazone. That is C double bond NH C6H5. Similarly, at second carbon is also there is a formation of carbon nitrogen double bond C6H5, and the remaining group is as it is. And the remaining group, it is as it is. This is your OH, then this is your HOH, then this is your HOH, and finally CS2OH. So this is the derivative of this glucose molecule, and it is known as ozazone. Okay, ozazone formation, ozazone formation. So you should keep in mind. So whenever the glucose molecule will react with your phenylhydrazine, okay, so it will forms its derivative, and there is a formation of carbon nitrogen double bond at carbon number 1 and carbon number 2, and it is considered as a ozazone. So it is very useful to identify either the sugar is glucose or not. Okay, so whenever glucose molecule is there, it will react with phenylhydrazine and it will form the ozazone. When if the sugar, it is not if the compound, it is not a carbohydrate or it is not a glucose molecule, then there is no reaction with your phenylhydrazine. So the mechanism is very complicated, so we will discuss the mechanism of this phenylhydrazine, reaction of glucose with phenylhydrazine, in Google Meet or Zoom meeting. Okay, so at least you should know the reaction. That is, whenever the glucose molecule react with excess phenylhydrazine, it will convert into the ozazone. Similarly, we know that this glucose and mannose, they are epimers, at carbon number 2. They are epimers at carbon number 2. So if you write this two different substituent, that is, this is your OH and this is your hydrogen, and then this glucose molecule is converted into mannose. This glucose molecule is converted into mannose, because glucose and mannose both are epimers of each other at carbon number 2, and therefore this mannose is also gives the same ozazone product in presence of three molecules of phenylhydrazine. So both glucose and mannose gives the same product. Okay, because they are epimers at carbon number 2, and this reaction is going on at carbon number 2. Therefore this reaction is very important. Both glucose and mannose, they will give the formation of ozazone. So this is the second reaction, that is reaction with phenylhydrazine. Okay, the mechanism we will discuss in the Google Meet or Zoom Meet. Let's discuss the next reaction, that is a reaction with base. Reaction with base. Okay, reaction with base. So what happened when the base is react? So we already discussed the reactions of this carbohydrate with oxidizing agent, with reducing agent, then reaction with phenylhydrazine, and we are very much interested the reactions of this carbohydrate molecule or sugar molecule with base. Okay, so if you consider this sugar, if you take the sugar molecule in presence of base, okay, it will gives extensive isomerization. extensive isomerization it will gives extensive isomerization. And if we see the example, okay, so it will shows extensive isomerization. So what is this extensive isomerization? So in presence of alkali, means in presence of base, the D-glucose rearrange the D-glucose, it undergo isomerization reaction and gives a mixture of D-glucose, a mixture of D-glucose, a mixture of D-glucose. Okay, so it will gives a mixture of D-glucose, second mannose and fructose, mannose and fructose. So you should keep in mind whenever the carbohydrate molecule or the sugar molecule react with your base, then there is extensive isomerization, and in this extensive isomerization, this glucose molecule, it will gives D-glucose, D-mannose, and D-fructose. So if you consider the reaction, so let us consider the reaction of this D-glucose with this base. So if you consider the reaction of this D-glucose with base, okay, reaction of this. So we can write here, this is your C double bond OH, okay. Then what happened? This is your COH, okay, and the remaining group is same. So we are considering this is your R group. This is your R group. So what happened? The base. So this is your D-glucose molecule. D-glucose molecule. So base. So in this case, base will abstract this proton, and the bond will get shift here, and there should be O minus. Okay. So what you get here? So if you see the mechanism, that is, the base will abstract this proton, and there is a formation of carbon-carbon double bond. So here what you get here, and this O minus immediately takes the protons. So what you get here, C OH H. So this is your carbon number 1, 2, okay, and the remaining carbon. So there is a double bond formation between carbon number 1 and carbon number 2. Here there should be OH is there. There should be OH is there, okay, and the remaining R group is as it is. The remaining R group is as it is, okay. So it is called a trans indiol. So this product, whatever the intermediate is formed, it is called trans indiol. In means there is a carbon-carbon double bond, and both carbon containing hydroxyl group, and therefore it is considered as a trans indiol. So base react with glucose molecule, and then there is a formation of trans indiol. Again, the isomerization reaction is continuous. So the equilibrium is developed in this reaction. So again, the base will abstract this proton, okay, and the bond between oxygen and hydrogen will be break, okay, and this bond will be shift here. This bond will be shift here. So what you get here? So the lone pair on carbon is nothing but there is a one more hydrogen is there. So what you get here? Carbon is there, okay, and then the OH group is there, okay, then there is hydrogen is there. So if you see this, and one more hydrogen is there after breaking of this carbon-carbon double bond. So we get CS2, so OH. Then here there is a formation of double bond, that is C double bond O, and the remaining is R group. And the remaining is R group. The remaining is R group. So the reaction, it is very simple. So this base will abstract the one of the proton of carbon second and convert into the glucose into transindiol. Again, transindiol react with your base, and there is a formation of that is formation of C double bond O at carbon number second, and the remaining is R group. So if we see this molecule, this is your ketose, and this is your fructose molecule. This is your fructose molecule. So D-glucose on reaction with base, there is a formation of transindiol, and this transindiol again reaction with base, there is a formation of fructose. There is a formation of this fructose. Again, if you see this reaction, okay, if you see this reaction is continue, okay, this reaction is continue. So we can write here how this reaction is going on. So this reaction, again the base will abstract, okay, again here we can write, Again, the base will abstract this proton, and there is a formation of C double bond O. Okay, there is a formation of C double bond O, and this bond, if you see this mechanism, so I will draw here. So first, on reaction, with the D-glucose, there is a formation of CS2. There is a formation of CS2 OH, C double bond O. Okay, C double bond O. Then there is a formation of fructose molecule. Okay, so we already discussed up to this. It is C double bond O, OH, H, and then there is a H, OH. Okay, then there is a H, OH, and finally this is your CS2 OH groups. So we get fructose. So first, the reaction of glucose with base, there is a formation of trans-indole. Then trans-indole, again the base will abstract the proton of the carbon second hydroxyl group and convert into the fructose. Again, what happened? So in this case, if you see this is carbon 1, carbon 2, 3, 4, 5 and 6.